This video presents Daisen, a framework for visualizing detailed GPU execution. GPUs are devices that have a large number of cores, and each core can run a large number of threads. GPU hardware designers need to find subtle mechanisms in each core that causes performance issues. This is very challenging without a visualization tool, but Daisen can help. Daisen first provides a data collection library that can be built into a hardware simulator. As we integrate the tool with MGPU a GPU simulator, a user can simply add -trace-viz command to collect data in a MySQL database. After finishing the data collection, a user can start the visualization tool as a server, and multiple users can use the web-based visualization interface simultaneously. When a user types the URL in the browser, the user first sees the overview panel. We use small multiples to show how performance metrics change over time in each digital circuit component. We show the name of the component on the top left corner and also show the figure below the title. The x-axis of the figure is the time in the execution, and there are two curves in each figure. Users can select what metrics they want to visualize with each curve. They can also turn off one curve by unselecting a metric in the drop-down menu. The metrics provided by Daisen are general and can carry rich information. For example, using the buffer pressure metrics, we can see that there are a large number of requests waiting in the buffer of the L1 cache. By using the metric called number of concurrent tasks, we can see that the utilization of this SIMD unit is only 15%, which is under the desired value. Since there is a large number of components in a GPU, we allow users to switch between pages to browse all the components. Users can also use the filter box to directly jump to the components with certain names. In addition, users may want to make customized combination of the component, and they can achieve this by using a special syntax to make any combination. By default, each widget shows the duration of the whole simulation. Users can zoom in and out with mouse wheels and move the x-axis by dragging. When one widget updates the x-axis, all other widgets follow. This feature creates an alignment effect so that users can easily compare the metrics of different components. Overall, the overview panel enables users to find which component causes performance issues at a certain time. But how they know what is the root cause of the issue? For example, we can see this cache is not processing enough requests since the buffer pressure is way below 1. How can we know what the cause is? To have a deeper understanding of the execution, a user can click on the name of the component. The interface switches to another layout with a task view, a component view, and a legend on the right side. The component view shows all the tasks that are executing in the component hierarchically. For example, here we see this component is processing a read request, and internally, it is processing another request that has a category of L1 transaction. Furthermore, to process the L1 transaction, the L1 cache initiates another memory read task, which is a request sent to an L1 cache. We see that there are big gaps between the tasks in this L1 cache, suggesting that the L1 has low utilization. We need to check why the L1 cache cannot receive enough requests. To check where this task comes from, we first need to click on the task to enable the task view. The task view shows the task we just clicked as the current task. We can also see the parent task and the subtask of the current task. As we click on the parent task becomes the current task, and we can navigate the task hierarchy by keep clicking on the parent task. The component view always shows the component where the current task is executed. As we move up the task hierarchy, we see that we moved to a component that is called address translator, and the tasks here are still sparsely executed. As we keep going up the task hierarchy, we finally arrive at the compute unit, where the instructions are executed. We can identify the instruction that issues the memory request. The key information we need to check is what the component is doing right before executing the memory instruction. To first have an overview of what is executing in the compute unit, We can hover on the legend items to locate all the tasks of a certain type. We see all the big rectangles are workgroups. Each workgroup owns one wavefront, and each wavefront executes many instructions. The instructions that takes the longest time are vector memory instructions. Some other instructions take short times, including VLU instructions and scalar instructions. Right before the instruction, we see that only a few wavefronts are executing. When we start this instruction, all other wavefronts are working on VLU or scalar instructions and do not have memory requests to the memory system. Here, the compute unit is only executing 3 to 5 wavefronts. Considering that a compute unit can run 40 wavefronts in parallel, the performance issue comes from the fact that workgroup dispatcher is not sending workgroup fast enough to keep the compute unit busy. After finding this performance issue, a GPU hardware designer can try to improve the dispatcher speed. Here, we change the parameter in the simulator and we visualize the GPU execution again. As a comparison, we can see the execution time is reduced from 55 microseconds to 44 microseconds. As we compare the component view of a compute unit, we can see that on the 6th row, there are more workgroups, suggesting the compute unit can run more wavefronts at the same time. So far, we have used a real-world case study to walk you through how to use the Daisen visualization tool. Overall, we can see it is a universal visualization tool for hardware designers to inspect the extremely low-level execution unit. It is handy in identifying performance issues and verify the performance improvement of a new hardware design. As of today, Daisen has already been used to facilitate computing system research. If you like it, feel free to give it a try.